12,800 years ago, something happened. The earth burned. Ice melted. Megafauna extinct. The Clovis people vanished. Then, agriculture. Temples. Göbekli Tepe. Did a comet destroy an Ice Age civilization? Or is this archaeology's biggest controversy based on flawed science? The Younger Dryas. Geologists call it Greenland Stadial GS1. 12,870 years ago, give or take 30 years, the northern hemisphere plunges back into Ice Age conditions. Abruptly. In just a few years. Greenland temperatures drop 4 to 10 degrees Celsius. Europe cools by 2 to 6 degrees. North America sees dramatic regional cooling. This isn't gradual climate change. The ice cores show it, sharp, sudden, unmistakable. The warming interglacial that began thousands of years earlier, the one that should have continued, stops. Reverses. Ice sheets that were retreating start advancing again. Sea ice expands. The Atlantic overturning circulation, the ocean conveyor belt that carries heat northward, weakens or shuts down. And it lasts. For over 1,000 years. The cold snap doesn't end until 11,700 years ago, when warming resumes, again, abruptly. This is established science. Mainstream geology. No one debates that the Younger Dryas happened. The question is, what caused it? The traditional explanation, meltwater from retreating ice sheets floods into the North Atlantic, disrupting ocean circulation. Cold water stops the heat pump. The North freezes. But in 2007, a group of scientists proposed something different. Something more catastrophic. A comet. Across North America, archaeologists and geologists have found something peculiar. A layer of dark sediment. Black, organic-rich, sometimes charcoal-heavy. They call it the black mat. It appears at dozens of sites. Different regions. Different ecosystems. But always at the same chronological horizon, the Younger Dryas boundary. Around 12,800 years ago. At some sites, it's a few centimeters thick. At others, thicker. It sits between layers of Pleistocene-age sediment below and Holocene-age sediment above. Geologists have studied these layers for decades. Typically, they're interpreted as wetland deposits or lacustrine sediments, swamp layers formed during the cooler, wetter conditions of the Younger Dryas. But starting in the 2000s, researchers began looking at what's inside the black mat. And that's where things get interesting. Magnetic spherules. Tiny glass-like particles. Carbon spherules. Nanodiamonds. Platinum. These aren't typical wetland deposits. In 2020, a major synthesis study documented abundance peaks in these materials across the Younger Dryas boundary layer. Not just in North America. Europe. The Levant. Even South America. The proponents of the impact hypothesis argue these are markers of a cosmic event. High-energy, high-temperature processes. The kind you'd see from an airburst or impact. The critics? They say these materials can form terrestrially. Wildfires. Volcanic activity. Normal geological processes. But both sides agree, something shows up in the sediment record at 12,800 years ago. The debate is what it means. At the same time as the Younger Dryas cold snap, North America's megafauna disappear. Mammoths. Mastodons. Saber-toothed cats. Giant ground sloths. American horses and camels. Short-faced bears. Dire wolves. Over 70% of North American genera weighing more than 44 kilograms go extinct. The timing is striking. High-precision radiocarbon dating places most of these extinctions at or near the Younger Dryas onset, around 13,000 to 12,750 years ago. This isn't just North America. South America loses its megafauna too. Giant armadillos. Glyptodonts. Giant sloths. For decades, paleontologists have debated why. Two main theories dominated. Overkill, humans arrived in the Americas and hunted these animals to extinction. Megafauna had never encountered human hunters before. They had no fear. No defense. The Clovis people, with their sophisticated stone spear points, wiped them out. Climate change, the rapidly shifting climate disrupted habitats. Food sources changed. Migration patterns broke down. The animals couldn't adapt fast enough. Both explanations have evidence. Both have problems. But the Younger Dryas Impact Hypothesis adds a third possibility, a cosmic catastrophe. Massive wildfires. Ecosystem collapse. Sudden environmental shock so severe that even large, adaptable animals couldn't survive. If a comet airburst or impact triggered continent-wide fires and abrupt cooling, it could explain the speed and scale of the extinctions. But again, that's a big if. The Clovis culture. North America's first widespread archaeological culture. Named after Clovis, New Mexico, where distinctive stone spear points were first discovered in the 1920s. Clovis points are beautiful. Fluted, meaning a channel is carved down the center to fit onto a spear shaft. Symmetrical. Expertly knapped. Found across North America from coast to coast. They're also precisely dated. Radiocarbon chronology places the Clovis technocomplex between 13,050 and 12,750 years ago. And then, they disappear. At the beginning of the Younger Dryas, Clovis points stop showing up in the archaeological record. The culture fragments into regional Paleo-Indian complexes. Different tool technologies. Different strategies. Did the Clovis people die out? No. Their descendants survived. But the widespread, unified Clovis tradition, gone. Something disrupted them. The climate shift? The megafauna extinction, which would have eliminated their primary food sources. Or something more sudden? The impact hypothesis suggests a catastrophic event. A comet airburst that destroyed settlements, triggered massive fires, and forced survivors to adapt or migrate. Again, the timing lines up. Clovis ends at the Younger Dryas boundary. The megafauna extinctions happen at the Younger Dryas boundary. The black mat layer forms at the Younger Dryas boundary. But correlation isn't causation. Critics point out that Clovis was already evolving. The culture wasn't static. Its disappearance might simply reflect adaptation to changing conditions, not destruction. Still, it's striking. The most successful culture in Ice Age North America vanishes at the exact moment that everything else goes wrong. Southeastern Turkey. The foothills of the Taurus Mountains. Göbekli Tepe. Potbelly Hill. In 1994, German archaeologist Klaus Schmidt begins excavating what looks like a burial mound. He uncovers something no one expected. Massive stone pillars. T-shaped. Some over 5 meters tall. Weighing 10 to 20 tons. Arranged in circular enclosures. Carved with animals. Foxes. Boars. Snakes. Vultures. Lions. Scorpions. Intricate relief carvings in limestone. And the dating? 10th millennium BCE. Around 11,500 to 10,000 years ago. This makes Göbekli Tepe older than pottery. Older than writing. Older than agriculture, at least, older than widespread agriculture. The people who built this were hunter-gatherers. They hadn't domesticated plants or animals yet. They lived by hunting gazelle and gathering wild grains. And yet they quarried, transported, carved, and erected multi-ton pillars. They built monumental architecture. They created complex religious or ceremonial sites. Göbekli Tepe sits right at the end of the Younger Dryas. Construction begins around 9,700 BCE, just as the cold period ends and the climate warms. Some researchers see a connection. The Younger Dryas forced humans to adapt. Wild grain harvesting became more systematic. Settlements grew. Social organization became more complex. And in the aftermath, temples. Graham Hancock and other alternative historians see something else. Göbekli Tepe as evidence of a lost civilization. Knowledge-bearers who survived the Younger Dryas cataclysm and taught hunter-gatherers how to build. Mainstream archaeologists reject that. They see Göbekli Tepe as proof that hunter-gatherers were more capable and organized than we assumed. No lost civilization required. But everyone agrees, Göbekli Tepe is revolutionary. And its timing, right after the Younger Dryas, is remarkable. So now we have the pieces. Abrupt climate catastrophe, mass extinction, cultural collapse, then monumental construction. What caused the Younger Dryas? That's the question a group of scientists set out to answer in 2007. 2007, a paper appears in the Proceedings of the National Academy of Sciences. The title, Evidence for an Extraterrestrial Impact 12,900 Years Ago that Contributed to the Megafaunal Extinctions and the Younger Dryas Cooling. The lead author, Richard Firestone, a nuclear physicist. Co-authors include James Kennett, a respected geologist from UC Santa Barbara, and over 20 other researchers. Their claim, a comet or asteroid fragmented in Earth's atmosphere and exploded over North America around 12,900 years ago. Multiple airbursts. Maybe impacts. The energy released would have been catastrophic. Continent-wide wildfires. Shockwaves. Immediate environmental devastation. The impact hypothesis argues this event triggered the Younger Dryas cooling, by throwing debris into the atmosphere, disrupting ocean circulation, or both. It explains the megafauna extinctions, animals burned in fires, suffocated by smoke, or starved when their habitats were destroyed. It explains the Clovis disappearance, human populations collapsed or scattered. And the evidence? The paper lists a suite of impact markers found in the Younger Dryas boundary layer: magnetic spherules, carbon spherules, nanodiamonds, fullerenes, iridium, charcoal, soot. The response from the scientific community was immediate. Some were intrigued. Many were skeptical. Because extraordinary claims require extraordinary evidence. And this was an extraordinary claim. If confirmed, it would rewrite our understanding of the Pleistocene-Holocene transition. It would vindicate neo-catastrophism, the idea that sudden, violent events shape Earth's history, not just gradual processes. But if wrong, it would be one of the biggest misfires in modern archaeology. One of the most cited pieces of evidence, the platinum spike. Greenland ice cores, specifically the GISP2 core, show a sharp abundance peak in platinum at a depth corresponding to roughly 12,900 years ago. Platinum is rare on Earth's surface. But it's common in asteroids and comets. If a cosmic object hit Earth or exploded in the atmosphere, it could deposit platinum in the environment. The spike in the ice core would be a geochemical fingerprint of the impact. Proponents point to this as the smoking gun. A clear, datable signal of extraterrestrial material entering Earth's system at exactly the right time. But here's where it gets complicated. In 2025, a new study took a closer look at that platinum anomaly. They analyzed the timing, the geochemical signature, and the duration. Their conclusion? The platinum spike occurs after the initial Younger Dryas cooling, by several decades. It doesn't line up with the onset. And the chemical signature looks more consistent with volcanic fissure eruptions, not a single impact event. The spike lasts about 14 years in the ice record. That's too long for an instantaneous impact. But it fits volcanic activity, ongoing eruptions depositing platinum-rich aerosols. So is the platinum spike evidence of impact or volcanism? The debate continues. Proponents argue the ice core dating is uncertain and that multiple impacts over several years could produce a prolonged signal. Critics say the burden of proof is on the impact hypothesis, and the platinum data doesn't meet that burden. Beyond platinum, the impact hypothesis rests on other markers. Nanodiamonds. Melt glass. Materials that require extreme temperatures and pressures to form. Nanodiamonds are microscopic diamond crystals. They can form in several ways, deep in the Earth's mantle, in certain types of meteorites, or during high-energy impact events. The 2007 paper reported nanodiamonds in the Younger Dryas boundary layer at multiple sites. The team argued these were impact-related. But subsequent studies have been mixed. Some labs replicated the findings. Others didn't. Some researchers question whether the particles identified as nanodiamonds are actually something else, organic carbon structures, for example, that can look similar under certain imaging techniques. Then there's melt glass. In 2020, researchers published findings from Abu Huraira, Syria, a village site dating to the Younger Dryas period. They found glass-like particles in the YD boundary layer. Not just any glass. Melt glass containing minerals that only form at temperatures above 1,800 to 2,300 degrees Celsius. Corundum, mullite, sucite. These require extreme heat. The team argued this was evidence of a cosmic airburst, a comet fragment exploding in the atmosphere, generating a fireball hot enough to melt sand and rock. They dated the layer to 12,825 years ago, give or take 55 years. Right at the Younger Dryas onset. But critics raised objections. Could the glass form from sustained, intense wildfires? From lightning strikes hitting silica-rich soil? From human activities like pottery firing in later periods? The Abu Huraira team addressed these alternatives and argued the evidence pointed to airburst. But the debate isn't settled. Similar melt glass has been reported at other sites. Chile, North America. If confirmed across multiple continents, it would be powerful evidence. But replication is key. And so far, not every claimed impact marker has held up under independent testing. The eastern seaboard of the United States. From New Jersey to Florida. Hundreds of thousands, maybe 500,000, elliptical depressions dot the Atlantic coastal plain. They're called Carolina bays. They're shallow, oval-shaped, mostly aligned in a northwest-southeast orientation. Filled with wetlands, lakes, or forest. For decades, geologists have studied them. The question, how did they form? Traditional explanations include wind action, wave erosion from ancient lakes, dissolution of underlying limestone, or periglacial processes during the Ice Age. But some proponents of the Younger Dryas impact hypothesis see something else. Impact craters. Or secondary impact features created by ejecta from a larger impact. The alignment, they argue, points to a directional source. If a comet fragmented over the Laurentide ice sheet and exploded, debris and ice chunks could have been hurled southeast, creating the Carolina bays on impact. It's a dramatic idea. And if true, it would be physical evidence of a massive impact event. But mainstream geology doesn't support this. Optically stimulated luminescence dating, a technique that measures when sediment was last exposed to sunlight, shows Carolina bays formed over a wide range of times. Some are over 100,000 years old. Some are just 2,000 years old. They're not all the same age. They didn't form in a single event. And their internal stratigraphy, the layering of sediment inside them, is undisturbed. If they were impact craters, you'd expect shocked quartz, shattered rock layers, ejecta deposits. You don't see that. So the Carolina bays remain an interesting geological feature. But not evidence of the Younger Dryas impact. Proponents counter that not all bays need to be impact-related, just some. But the burden of proof hasn't been met. Syria. The Euphrates River Valley. Abu Huraira. One of the most important Neolithic sites in the Middle East. People lived here continuously from about 13,000 to 7,500 years ago. They transitioned from hunter-gatherers to early farmers. They domesticated wheat and barley. They built permanent structures. And then, at the Younger Dryas boundary, something happened. In 2020, researchers published a detailed study of the site's YDH layer. They found melt glass. Lots of it. Tiny glass spherules and fragments embedded in the sediment. The glass contains minerals that only form at temperatures above 1,800 degrees Celsius. In some samples, over 2,300 degrees. Corundum, the mineral that forms rubies and sapphires. Mullite, a high-temperature aluminum silicate. Sucite, a material normally found in meteorites. The team argues this could only come from a cosmic airburst. A comet fragment exploding in the atmosphere directly above the village, generating a fireball so intense it melted the sand and soil. They calculated the energy required, equivalent to a small nuclear weapon. If true, Abu Huraira would be direct evidence of an impact event at the Younger Dryas onset. But skeptics raise questions. Could the melt glass be intrusive, from a later period, mixed into earlier layers? Could it form from other high-temperature processes? The researchers address these concerns. They argue the stratigraphic context is secure. The glass is in situ, not intrusive. And no terrestrial process, wildfires, lightning, even volcanic activity, reaches the temperatures required to form these specific minerals. Abu Huraira is now underwater, submerged by a dam. The site can't be re-excavated. So independent verification is difficult. But the study's authors stand by their conclusion: Abu Huraira was destroyed by a cosmic airburst 12,800 years ago. If replicated at other sites, this would be game-changing evidence. Greenland. The GISP2 and NGRIP ice cores. Frozen archives of Earth's atmospheric history. Every year, snow falls on the ice sheet. It compresses into ice. Atmospheric particles, dust, volcanic ash, cosmic debris, get trapped in the layers. By drilling deep into the ice and analyzing each layer, scientists reconstruct past climates and events. The Younger Dryas is clearly visible in the cores. The temperature drop. The changes in atmospheric circulation. It's all there. But what about evidence of impact? Proponents point to several markers. The platinum spike we discussed earlier. Elevated levels of ammonia, suggesting widespread biomass burning, increased dust, from disrupted ecosystems, a sharp rise in nitrate, possibly from atmospheric heating during an airburst. Taken together, they argue, these signals point to a catastrophic event. But recent studies have complicated the picture. In 2024 and 2025, multiple research teams reanalyzed the Greenland ice core data. One study focused on the platinum anomaly. Their findings. The platinum spike occurs after the onset of Younger Dryas cooling, by about 30 to 50 years. The spike lasts about 14 years, not instantaneous as you'd expect from an impact. The geochemical signature matches volcanic emissions, not cosmic material. High volcanic sulfate levels in the cores coincide with the YD onset, suggesting major eruptions. Their conclusion: the platinum anomaly is volcanogenic. Fissure-style volcanic eruptions in Iceland or elsewhere could produce the observed pattern. Another 2025 study reported shocked quartz at 3 classic Clovis-associated sites in the U.S., Murray Springs in Arizona, Blackwater Draw in New Mexico, and Arlington Canyon in California. Shocked quartz is a commonly accepted impact marker. It forms when quartz crystals are subjected to extreme pressure, like from a meteor impact. The study argues these findings support low-altitude cometary airbursts at the Younger Dryas boundary. But critics remain unconvinced. Shocked quartz can also form tectonically or from lightning strikes, though it's rare. And 3 sites isn't enough for continental-scale impact. So where does the ice core evidence leave us? The Younger Dryas onset is real. The climate shift is undeniable. But whether it was triggered by impact, volcanism, ocean circulation changes, or some combination remains contested. The ice cores show something happened. The question is, what? From the moment the 2007 paper appeared, mainstream archaeology and geology raised objections. Not out of dogma. Not to suppress a new idea. But because the hypothesis made claims that conflicted with established evidence and physical plausibility. First, the impact physics. If a comet large enough to cause continent-wide devastation hit or exploded over North America, where's the crater? Proponents suggest airbursts, explosions in the atmosphere that leave no crater. Like Tunguska in 1908, where a meteor exploded over Siberia, flattening 2,000 square kilometers of forest but leaving no impact structure. But Tunguska was regional, not continental. The Younger Dryas hypothesis requires multiple airbursts across a vast area, all at the same time. That's a very specific scenario. Second, the markers. Critics argue that many of the claimed impact proxies aren't unique to cosmic events. Magnetic spherules can form in forest fires, industrial processes, or volcanic eruptions. Carbon spherules are common in charcoal-rich sediments. Platinum can come from volcanic sources, as we've seen. Nanodiamonds? Controversial. Some labs find them, others don't. The identification techniques are debated. Third, the chronology. Not all sites show the same markers at the same time. Some claimed YD boundary layers date to different periods. Stratigraphic integrity is questioned at several key sites. Vance Holliday, a prominent geoarchaeologist, has been one of the most vocal critics. He argues the hypothesis suffers from confirmation bias. Researchers find what they're looking for, but ignore inconsistencies. Todd Suravel and others conducted independent tests and failed to replicate the findings. We'll get to that in a moment. The mainstream position isn't that nothing happened at the Younger Dryas boundary. It's that the evidence for an extraterrestrial impact doesn't meet the standards required for such an extraordinary claim. Ocean circulation disruption. Climate feedback loops. These are sufficient to explain the Younger Dryas without invoking comets. Science advances through replication. If a finding is real, independent researchers should be able to reproduce it. In the case of the Younger Dryas impact hypothesis, replication has been inconsistent. One of the most damaging challenges came from a blind test at Lubbock Lake, Texas. Researchers collected sediment samples from above, within, and below the claimed Younger Dryas boundary layer, the black mat. They sent these samples to multiple labs without revealing which samples came from which layer. Blind testing. The gold standard. The results? Different labs using different methods came to different conclusions. Some identified microspherules in the YD layer. Others found them in younger layers, sediments dated to 11,500 years ago or less, well after the Younger Dryas. The study concluded that the claimed impact proxies weren't unique to the YD boundary and that identification was subjective. What one researcher calls an impact spherule, another identifies as a coal ash particle or a fungal spore. Other replication attempts have had mixed results. Some studies confirm nanodiamonds, others don't. Some find platinum anomalies, others attribute them to contamination or volcanic sources. And there have been retractions. Papers claiming certain evidence have been withdrawn or heavily criticized after independent review. This doesn't mean the entire hypothesis is wrong. But it does mean the evidence base is shakier than proponents initially claimed. In science, reproducibility matters. And so far, the Younger Dryas impact hypothesis hasn't achieved the consistent replication needed to convince the mainstream. Enter Graham Hancock, British author, journalist, and the most prominent proponent of the lost civilization theory. Hancock isn't an archaeologist. He's a researcher and writer who synthesizes evidence from multiple disciplines, archaeology, geology, mythology, into a grand narrative. In 2015, he published Magicians of the Gods, a follow-up to his controversial 1995 bestseller Fingerprints of the Gods. The thesis: an advanced Ice Age civilization existed before the Younger Dryas. When the comet struck, this civilization was destroyed. Survivors scattered across the globe, teaching hunter-gatherers agriculture, astronomy, and monumental construction. Göbekli Tepe, he argues, is evidence of this knowledge transfer. The site's sophistication, its massive pillars, precise carvings, astronomical alignments, suggests it wasn't built by simple hunter-gatherers. It was built with the guidance of survivors who possessed advanced knowledge. The same pattern, Hancock claims, appears elsewhere. The pyramids of Egypt. The megalithic sites of South America. Angkor Wat. All built with techniques that seem too advanced for their supposed builders. Hancock embraces the Younger Dryas impact hypothesis enthusiastically. It provides a mechanism, the catastrophic event that destroyed his lost civilization. He collaborated with Randall Carlson, a geologist who specializes in catastrophist interpretations of Earth's history. Together, they've appeared on podcasts, documentaries, and Netflix's Ancient Apocalypse series, reaching millions. Hancock is a compelling storyteller. He presents the evidence dramatically, weaving together geology, mythology, and alternative archaeology into a narrative that feels revelatory. But mainstream archaeologists have serious problems with his approach. The lost civilization theory is separate from the impact hypothesis. You can accept that a comet struck without believing in a lost civilization. And vice versa. But Hancock links them. The comet destroyed the civilization. The survivors became the gods and culture heroes of later myths. What's the evidence? Hancock points to advanced megalithic construction at sites like Göbekli Tepe, the Egyptian pyramids, and Puma-Punka shared architectural and symbolic motifs across distant cultures, flood myths present in cultures, worldwide astronomical alignments in ancient monuments, the sudden appearance of agriculture and civilization after the Younger Dryas. To Hancock, these patterns suggest a common source, a lost civilization that seeded knowledge globally. But archaeologists counter with evidence. Göbekli Tepe was built by hunter-gatherers. The site shows no evidence of metallurgy, writing, or domesticated animals. It's made with stone tools and muscle power. Impressive, yes. But not impossible for organized human labor. The sudden appearance of agriculture isn't sudden. It's a process that took millennia, with clear developmental stages visible in the archaeological record. Domestication of plants and animals happened independently in multiple regions. Shared motifs? Humans are humans. We respond to similar environmental pressures in similar ways. Pyramids are stable structures, they emerge independently because they're practical for building tall monuments with primitive technology. Flood myths? Most early civilizations developed near rivers, which flood. Catastrophic floods are common in human experience. No global deluge required. Astronomical alignments? Ancient peoples were keen sky watchers. Their survival depended on seasonal cycles. Of course, they built monuments aligned with celestial events. The lost civilization theory requires erasing the archaeological record of gradual human development, the slow, hard-won progress from hunter-gatherers to complex societies. Archaeologists see Göbekli Tepe as proof that humans are more capable than we assumed. Hancock sees it as proof of external knowledge. Both can't be right. Randall Carlson. Geologist. Sacred geometrist. Catastrophist. Unlike Hancock, Carlson focuses on the physical evidence in the landscape. And he's particularly interested in one thing, the Missoula floods. During the last ice age, an ice dam in Montana repeatedly formed and collapsed. Each time it broke, it released a catastrophic flood, the largest freshwater floods in Earth's history. The Missoula floods carved the channeled scablands of Washington state. Massive coulees. Giant current ripples. Erratic boulders weighing thousands of tons, deposited hundreds of miles from their source. For decades, geologists dismissed catastrophist explanations. They believed in uniformitarianism, the principle that Earth's features form slowly, through gradual processes. But the Missoula floods proved that catastrophic events do shape the landscape. Geologist J. Harlan Bretz spent his career fighting to prove the floods happened. He was eventually vindicated. Carlson sees the Younger Dryas impact as another such event. A catastrophe that mainstream science initially dismisses but will eventually accept. He's documented glacial meltwater features, erratic boulder fields, and geological formations he interprets as evidence of rapid ice sheet collapse triggered by impact. He's not claiming a lost civilization. He's claiming a cosmic impact. And he argues the geological evidence supports it. Critics acknowledge that catastrophic floods happened. The Missoula floods are real. But they were caused by ice dam failures, not comet impacts. The question is whether the same catastrophist lens applies to the Younger Dryas. Or whether Carlson is seeing impacts where there are only ice dams. Why do archaeologists object so strongly to the lost civilization theory? It's not because they're closed-minded or protecting orthodoxy. It's because the theory erases the achievements of ancient peoples. When you claim that hunter-gatherers couldn't have built Göbekli Tepe without help from a lost civilization, you're saying those people weren't capable. You're denying them agency. But the archaeological record shows exactly how humans developed these capabilities. Stone tool technology evolves. Social organization becomes more complex. Symbolic thinking emerges. Ritual practices develop. Göbekli Tepe isn't evidence of a lost civilization. It's evidence that we underestimated hunter-gatherers. The same applies to every site Hancock cites. The pyramids weren't built by Atlanteans. They were built by Egyptians, using documented techniques, over documented time periods, with clear archaeological progression from earlier mastabas to later pyramids. South American megalithic sites? built by Andean cultures with sophisticated engineering knowledge, developed over centuries. The lost civilization theory skips over all of this. It imposes a fantasy narrative over hard-won archaeological evidence. And it's unfalsifiable. If you don't find evidence of the lost civilization, proponents say it was destroyed in the cataclysm. If you do find early human achievements, they say it proves the civilization existed. That's not how science works. As for the impact hypothesis itself, archaeologists are more open to it, if the evidence holds up. Many archaeologists acknowledge that something significant happened at the Younger Dryas boundary. Climate change, extinctions, cultural shifts. If a comet impact contributed, that's a testable hypothesis. But it requires rigorous evidence, reproducible findings, physical plausibility. So far, that bar hasn't been met. But the search continues. And that's how science should work. Let's separate what we know for certain from what's disputed. The Younger Dryas event is real. Around 12,870 years ago, the northern hemisphere experienced abrupt cooling. Greenland ice cores document a temperature drop of 4 to 10 degrees Celsius. This cooling lasted over 1,000 years before rapidly reversing around 11,700 years ago. This is established science. No one disputes it. Megafauna extinctions happened. Over 70% of North American genera weighing more than 44 kilograms went extinct around the Younger Dryas onset. Mammoths, mastodons, saber-toothed cats, gone within a relatively short time window. The Clovis culture disappeared or fragmented at the Younger Dryas boundary. High-precision radiocarbon dating places Clovis between 13,050 and 12,750 years ago, ending right at the YD onset. The black mat layer exists at dozens of sites across North America, dating to the Younger Dryas boundary. It contains elevated charcoal, indicating widespread fire activity. Göbekli Tepe was built by hunter-gatherers starting around 9,700 BCE, right at the end of the Younger Dryas. It's a revolutionary archaeological site, regardless of how it's interpreted. These facts are not in dispute. They're documented, dated, and accepted by mainstream science. The question is, what caused these events? And are they connected? Now, what's disputed? Whether a cosmic impact triggered the Younger Dryas. Proponents argue yes, based on impact markers in the YD boundary layer. Critics argue no, saying those markers aren't unique to impacts and haven't been consistently replicated. The platinum spike in Greenland ice. Proponents say it's evidence of extraterrestrial material. The 2025 reanalysis says it's volcanic and occurs after the YD onset, not at the trigger point. Nanodiamonds. Some labs find them in YD-age sediments. Others don't. The identification techniques are debated, and replication has been inconsistent. Melt glass at Abu Huraira and other sites. Proponents argue the high-temperature minerals prove cosmic airburst. Critics question the stratigraphic context and whether other processes could produce similar materials. Shocked quartz. The 2025 study reported it at 3 Clovis sites. That's new and significant, if verified. But 3 sites isn't enough for a continent-wide impact, and alternative formation mechanisms exist. Carolina bays as impact features. Mainstream geology rejects this. The bays formed over a wide time range, not in a single event. Whether Göbekli Tepe proves a lost civilization. Mainstream archaeology says no, it proves hunter-gatherers were more capable than assumed. Hancock says yes, it proves knowledge transfer from survivors. So the evidence is mixed. Some findings support the hypothesis. Others contradict it. And much depends on interpretation, how you read the data, what you accept as sufficient proof, and what alternative explanations you consider. This is normal in science. Controversial hypotheses take time to resolve. Evidence accumulates. Techniques improve. Eventually, consensus emerges, or the hypothesis is abandoned. The Younger Dryas Impact Hypothesis is still in that contested middle ground. It's critical to separate 2 questions. Did a comet impact contribute to the Younger Dryas? Did a lost civilization exist before the Younger Dryas? These are separate claims. You don't need a lost civilization to have an impact. And you don't need an impact to have human innovation. The impact hypothesis is a scientific question. It's testable. It makes predictions. If a comet struck, there should be physical evidence, craters, ejecta layers, shocked minerals, geochemical signatures. We can look for these. We can test them. The lost civilization theory is far harder to test. Hancock's version is unfalsifiable. If you don't find evidence, he says it was destroyed. If you do find early achievements, he says it proves survivors taught them. But the archaeological record is clear. Human development from the Paleolithic to the Neolithic is gradual, documented, and continuous. Tool technologies evolve. Social complexity increases. Symbolic behavior emerges. Agriculture develops independently in multiple regions. Göbekli Tepe fits into this progression. It's extraordinary, yes. But it doesn't require a lost civilization. It requires us to stop underestimating ancient peoples. The Younger Dryas may have accelerated certain developments. Climate stress can drive innovation. Wild grain cultivation became more systematic. Settlements grew. Social organization increased to manage resources. But that's not evidence of Atlantis. That's evidence of human adaptability. Graham Hancock has done one valuable thing. He's made millions of people interested in ancient history and archaeology. That's not nothing. But interest should lead to evidence, not fantasy. The real story of human development, from scattered hunter-gatherers to builders of monumental temples, is more impressive than any lost civilization myth. Because it's real. And it's ours. If not a comet, what caused the Younger Dryas? The leading explanation: meltwater pulse and ocean circulation disruption. As ice sheets retreated at the end of the last ice age, massive amounts of fresh water flooded into the North Atlantic. This disrupted the Atlantic meridional overturning circulation, the ocean conveyor belt that carries warm water northward. When the circulation weakened or shut down, Europe and North America stopped receiving tropical heat. Temperatures plummeted. Ice sheets advanced again. This model is consistent with ice core data, ocean sediment records, and climate modeling. No comet required. Volcanism is another factor. The 2025 study on the Greenland platinum spike argues that major volcanic eruptions occurred around the YD onset. Volcanic aerosols in the atmosphere can cause cooling. Volcanic emissions explain the geochemical signatures better than impact. Overkill and ecological stress explain the megafauna extinctions. Humans arrived in the Americas and hunted large animals that had no experience with human predators. Climate change disrupted habitats. The combination was deadly. No single catastrophic event needed. Just the intersection of human expansion, climate shifts, and ecosystem fragility. The Clovis disappearance? Cultural adaptation. When your primary prey goes extinct and the climate shifts, you change strategies. Regional Paleo-Indian complexes reflect that adaptation. Göbekli Tepe? The result of intensified resource use during the Younger Dryas. Hunter-gatherers became more sedentary to exploit wild grains. Sedentism led to larger social groups. Larger groups needed ritual structures to maintain cohesion. Hence, temples. No lost civilization required. Just humans responding to environmental pressures with ingenuity. These explanations aren't as dramatic as a comet, but they're supported by the evidence. Where does the debate stand in 2025? The Younger Dryas Impact Hypothesis has not achieved mainstream acceptance. Most archaeologists and geologists remain skeptical, but it hasn't been definitively disproven either. And that matters. Proponents continue to publish. The 2025 shocked quartz study adds a commonly accepted impact marker to the discussion. Abu Huraira's meltglass remains compelling, even if hard to verify. Critics continue to push back. The 2025 platinum reanalysis undermines one of the strongest pieces of evidence. Replication failures persist. The truth is probably complex. Maybe there was a cosmic event, but smaller than proponents claim. Maybe multiple factors combined: volcanism, ocean circulation, and a minor airburst. Or maybe the traditional explanation is correct, and the impact markers are coincidental or misinterpreted. Science works slowly. Decades from now, better dating techniques, more sites, improved analysis methods, these will clarify what happened. For now, the Younger Dryas Impact Hypothesis remains controversial. It has genuine scientific proponents. It has genuine scientific critics. Both sides are arguing in good faith, using evidence. That's how it should be. The lost civilization claim? That remains outside mainstream science. It's unfalsifiable, speculative, and unsupported by the archaeological record. But the impact hypothesis itself? Still an open question. 12,800 years ago, something happened. The Earth cooled. Megafauna went extinct. Cultures collapsed. And in the aftermath, humans built temples. Was it a comet? Was it ocean circulation? Was it volcanism? Was it all of the above? We don't know. Not yet. But we're looking. Researchers are drilling ice cores, excavating sites, analyzing sediments. Every year, the picture becomes clearer. What we do know is this: the Younger Dryas was a turning point in human history. It ended the Ice Age. It reshaped ecosystems. It pushed humans to adapt. And out of that adaptation came agriculture, settlements, civilization. Whether a comet triggered it or not, the Younger Dryas changed us. Göbekli Tepe stands as proof. Not of a lost civilization, but of human resilience. Of our ability to create meaning, beauty, and structure even in the aftermath of catastrophe. The search for answers continues. And that's the point. Science isn't about having all the answers. It's about asking the right questions. Testing hypotheses. Following evidence wherever it leads. The Younger Dryas Impact Hypothesis may be right. It may be wrong. It may be partially correct. But the debate itself, the process of investigating, questioning, testing, that's how we learn. So here's what you should take away. The Younger Dryas was real and catastrophic. The cause is still debated. Evidence for impact exists but is contested. The lost civilization claim is separate and unsupported. Göbekli Tepe is a human achievement, not proof of Atlantis. Science works by testing, not by storytelling. 12,800 years ago, something happened. We're still figuring out what. And that's exactly how it should be. This is Underlight Histories, where the overlooked is illuminated. Thank you for watching. Like and subscribe. See you next time.